Okay, so oxo acids, first of all, what are oxo acids? There is an oxo group which is C double bond O or S double bond O, and there is a hydroxyl or OH group attached to the same atom. So these kind of structure, this is called the oxo acids. So sulfuric acid, phosphoric acid, right, carbonic acid, these are all examples of oxo acids. Yeah, append of it, C double bond O, S double bond O. So we have already seen many reactions where alkali metals form the salts with the acids. Okay. Okay, done. This is done. Okay, so next, this is under properties. You can write. So this is for carbonates and hydrogen carbonates. Okay, so stability of carbonates and hydrogen carbonates increases from the group. This is from lithium carbonate to cesium carbonate. So stability means the thermal state or on heating, most stable will be cesium carbonate, least stable will be, right? So like lithium carbonate will decompose on heating due to Li2O and CO2. So this will most easily decompose, and cesium carbonate will be most difficult to decompose. So that is the meaning of stability, okay, towards heat. Actually, a lot of it is you can say it's application of the periodic property structure, okay, and chemical bonding is application of the three, and maybe some physical chemistry other than that. Okay, so this point you can note electropositive. So the you can say the ionic character increases down the group, so the stability increases. That is the meaning of electropositive character. Okay, so done, this point is done. So on heating, lithium carbonate decomposes into So its the reason is like lithium is very strong, has a very strong polarizing power. So you can say it almost takes one oxygen out of the carbonate, but polarizer is so much that it takes up oxygen and becomes oxide and CO2. Okay, and down the group the ionic character is more, and that is more stable towards heat. Yes, they are actually, but each one has like lithium and beryllium has similar characteristics. Okay. But boron, carbon, okay, nitrogen, oxygen, fluorine, they are non-metallic. They have different, but they are also have many properties which are different from their own groups, right? So lithium and magnesium, yes, they are similar. So yes, it also has. We'll see the similarities. We'll see in what ways they are similar. So like we said, group lithium and beryllium. We are considering its anomalous properties, or properties are different than its own group because of the very small size. Okay. And that results in the high polarizing power. Second point comes from the first. Okay. Small radius and relatively high charge, that is the high polarizing power. So because of that, lithium compounds have a covalent character, and they become soluble in organic solvents or non-polar solvents, because covalent character means less ionic or more non-polar. So in what ways lithium is different? Okay, the difference is what properties. Okay, so one is the lithium is much harder as compared to the other alkali metals, and boiling and melting point are higher than the rest of the alkali metals. Okay, but main focus here is our focus on the reactions and properties, chemical properties. So one point we discussed already, it is the strongest reducing agent. Okay, but reactivity wise actually it is much less reactive. Strongest reducing agent but least reactive, and reactivity actually increases down the road. And reducing strength is determined by the electrode potential. Okay, so it forms monoxide and nitride. So nitride is not formed by other alkali metals in reaction with air. Okay, mainly forms monoxide, whereas others form peroxide and superoxide. So second point, least reactive strongest reducing agent mainly forms monoxide and nitride, which is not formed by. So one property which is similar to magnesium. Magnesium also forms oxide and nitride. So that is one similarity. Okay, it's done. Everybody is done. What you were doing in the break, Pranav?
So I was buying this.
Huh?
To wait in the line.
For half an hour you're buying.
Wait and then walk back and it was already 9.
Where did you buy this from? So much queue? Half an hour of queue?
That day,
lady service credit card doesn't know how to type.
Yeah. Carrefour, we are inside DCC. Huh? That is anyway, that's far. 10 minutes it takes to walk.
oh my god.
Okay. So I'll tell you which point to write here. Okay. This point you can write. So it's so less stable that it does not exist in the solid form. And the stability increases down the group. Point 6 you can note. Okay. So this is again the difference. This is again an important point, that lithium nitrate gives lithium oxide and NO2. Okay, whereas other will be same for KNO3. Okay, cesium nitrate, rubidium they will give nitrite and O2. This gives oxide, NO2 and O2.
These are like the lower men.
Yes, so that's the anomalous behavior or difference. Does not give any LiNO2, does not give nitrite, it gives different. So okay, and this all note down. Okay, then Okay, so next points of similarities between that is the diagonal relationship. Okay, so they have, you see, they have very similar, especially the ionic radii is very similar, and atomic radii are also not very different. Okay, so points of similarity you can note. Okay, so from second point onward now. So both form nitride, that is an important point. Li3 and Mg3N2. So both of them will form oxides mainly and will not form any peroxide or superoxide. Fourth point. Okay, so fifth point, both will have significant covalent characters, so they are also soluble in organic solvent. Okay. So next we move on to important compounds of. So basically there are just two compounds, sodium carbonate and NaOH. So sodium carbonate, common name washing soda, and that is Na2CO2.10H2O. Okay, so without H2O, that is called anhydrous sodium carbonate. With 10H2O, that is your washing soda. Okay, so it's prepared by, and write this process by which is prepared is the solvent process. Okay, so solver process, what is it? So, okay, I'll tell you what to write here first. Let's understand this. The final step, like how it is prepared. So it's prepared by heating sodium hydrogen carbonate. Okay, and how sodium hydrogen carbonate is prepared, that is what the main solver process is. Okay, so see, the first reaction is this. You have ammonia, okay, and CO2 sparks to the constant solution of sodium chloride. With ammonia you get ammonium carbonate, okay, and ammonium carbonate reacts with CO2 to give ammonium bicarbonate, and that reacts with NaCl to give, okay, sodium hydrogen carbonate, and that is heated to give. Reactions are enough actually to understand the process. That is the solver process. So ammonium carbonate further gives ammonium hydrogen carbonate, NaCl gives sodium hydrogen carbonate, that on heating finally gives. Right. So that is your solver process. Okay, so this is the hydrogen sodium carbonate is less soluble, so it is precipitated out, and then it can be heated to give. Okay, and the NH3 which is being used can be recovered by this reaction. Okay, calcium hydroxide and CaCl2 as the byproduct ammonia is. Okay, and it can be reused in the first reaction. Here, yeah, it will not, basically it will not work without H2O. Ammonium, is that how it's found? But no, this something else might be required for that. Okay, this is done. Okay, so one point you can add here, we the same process we cannot use for potassium carbonate. The potassium hydrogen carbonate is formed is soluble, or it does not. Potassium hydrogen carbonate will not precipitate out, and you cannot use the same type of process of potassium hydrogen carbonate. So some other method will be used here. What is the formula of the compound you were telling me? You know the formula? But I think it will, without H2O, by heating, I think it gives that product. It's part of organic compounds. Okay, so in properties, you can note down this one, the last two properties. Okay, so that I already discussed, formula decahydrate NH2O. Okay, readily soluble in water. So you can note down on heating this gives monohydrate or dot H2O. Further heating it gives the, so this is called the anhydrous form, or without any kind of crystallization. Okay, and last point here. Okay, so this is anyway a general property. Okay, as you can say, sodium carbonate is a salt of strong base and weak acid. So on reaction with H2O, the solution is alkaline. Okay, so whichever is the stronger part, that determines whether the solution is acidic or basic. Uses you can just read. Okay, in the softening of hard water, you have used in one of the methods sodium carbonate. Compound is NaOH, also commonly called as caustic soda. It's prepared in this by electrolysis, and the cell or the container or the system is called the Cassar-Turner cell. Okay, it's produced by electrolysis of the sodium chloride solution, which is called brine. Okay, aqueous solution of sodium chloride. So at cathode there is reduction of sodium plus ions into sodium amalgam, and anode you get chlorine. Maybe it's mixed with something. It's not pure. Maybe it's a compound with something, and yeah, and it combines with sodium to give sodium. And then you react this with H2O. Okay. Amalgam is reacted with H2O to get the sodium hydroxide. and properties. Okay, so no need to write here, just you can read this. Nothing specific here. Okay, and uses. Okay, and last part is this for group 1. Okay, biological importance is also, you can just take this part. Okay, so the first point is basically trying to explain that the importance of sodium and potassium. It's very important ions for the human body, much more in amount than higher copper. Okay, so they have a lot of different roles in the biological process. This is primarily present within the cell fluids, and this is primarily outside the cells. Okay, done.